1. Objective. This goal of this lab is to understand and implement methods to obtain Z-transform in MATLAB and study its various forms. 2. Resources required. A computer. MATLAB 7.0 or higher. 3. Z-transform. In mathematics and signal processing, the Z-transform converts a discrete time domain signal, which is a sequence of real or complex numbers, into a complex frequency domain representation. The Z-transform, like many other integral transforms, can be defined as either a one-sided or two-sided transform. 3.1 Bilateral Z-transform. The bilateral or two-sided Z-transform of a discrete time signal xn is the function x, z, defined as equals z equals sigma infinity equals infinity. 3.2 Unilateral Z-transform. Alternatively, in cases where xn is defined only for n greater than or equal to 0, the single-sided or unilateral transform is defined as equals z equals sigma infinity equals 0. In signal processing, this definition is used when the signal is causal. 4.1 Symbolic representation of Z-transform. F equals strands, f equals strands, f, w. Sims n. A equals strands, 1/16 n, Digital Signal Processing Lab page 3. 4.2 Inverse Z-transform. F equals is trans, f equals is trans, f, k. Sims z. Is trans, 3 *z/ z plus 1. 4.3 Pole zero diagrams for a function in Z domain. Spline command computes and display the pole zero diagram of Z function. The command is spline, ba. To display the pole value, use root, a. To display the zero value, use root, b. MATLAB code. B equals 0 1 1, A equals 1 minus 2 3. Roots, A, roots, B. Spline, BA. The freq function computes and display the frequency response of given Z, transform of the function freq, BAFS. The impulse response of the system can be computed using IMPS, number den, Digital Signal Processing Lab page 4. 5.1 Z-transform conversions. TF2ZP converts rational Z-transform to zero-pole form. TF2SOS converts rational Z-transform to second-order section/factored form. ZP2TF converts zero-pole Z-transform to rational form. ZP2SOS converts zero-pole Z-transform to second-order section/factored form. SOS2TF converts second-order section/factored Z-transform to rational form. SOS2ZP converts second-order section/factored Z-transform to zero-pole form. Example. Let the given transfer function be in the rational form. Equals 2 4 plus 1 6 3 plus 4 4 2 plus 5 6 plus 32. 3 4 plus 3 3 1 5 2 plus 1 8 12. It is required to convert it into factored form, so that we can find the poles and zeros mathematically. By applying quadratic equation. MATLAB command required for converting rational form to factored form is SOS equals TF2 SOS, 2 16 44 56 32, 3 3 minus 15 18 minus 12. The factored form of G, Z, as evaluated by TF2 SOS B. Equals 0.667, 1 plus 6 1 plus 8 2, 1 plus 2 1 plus 2 2. 1 plus 2 1 4 2, 1 1 plus 2. Note, test all the MATLAB functions on the above transfer function. Modify code 3 for this purpose. 5.2 Partial fraction expansion. Consider the transfer function in the rational form. Equals 183. 183 plus 3241. Its partial fraction form is equals 0.36. 10.51 plus 0.24. 1 plus 0.331 plus 0.4. 1 plus 0.331, 2. RPK equals residues, 18,000, 18,3 minus 4 minus 1, / its reverse is BA equals residues, RPK, Digital Signal Processing Lab page 5. Code 1, example 3.3 of book. CLC. Sims n. xn equals 1/2, n plus, minus 1/3, n. xz equals strands, xn. DISP, xn equals, pretty, xn. DISP, xz, equals, pretty, xz. DISP, xz, equals. RXZ how equals simple, xz. Pretty, RXZ. DISP, xz, equals. Pretty, simplify, xz. Code 2, example 3.8 of book. CLC. Sims z. xz equals 1/1, 1/4, asterisk, z caret dash 1, asterisk, 1, 1/2, asterisk, z caret dash 1. DISP, xz, equals, pretty, xz. xn equals is trans, xz. DISP, xn equals, pretty, xn. Code 3. Number equals input, type in the numerator coefficients equals. Den equals input, type in the denominator coefficients equals. ZPK equals TF2ZP, number den. M equals ABS, P, percent to find distance from origin of poles. DISP, zeros are at, DISP, Z. DISP, poles are at, DISP, P. DISP, gain constant, DISP, K. DISP, radius of poles, DISP, M. SOS equals ZP2 SOS, ZPK. DISP, second order sections, DISP, real, SOS. Splane, number den, Digital Signal Processing Lab page 6. Digital Signal Processing Lab.